guys, so we are starting with interval notation, and you should have in front of you notes that look similar to this. Mine aren't filled in all the way, but yours have a lot of information that's already filled in. But I'm going to go through it first, and then give you time to practice, and hopefully everything will make sense by the end. So let's start here. But before I even do that, I'm going to take you back a little bit all the way to September, because if you notice, we have a couple symbols that look familiar. The first one is this one right here, the U that means union, or the N that means intersection. And if you remember at the beginning of the year, we talked about union and intersection when we did Venn diagrams. But to give you just a very quick recap of it, for example, if we had a set, and I'm just going to make these sets up, if we had a set of numbers like 1, 2, and 3, and we'll call that set A, and then we had another set of number that is set B, and let's say it had 2, 3, 5, and 7, right? And so you would have questions that what's the union of A versus the union of set A to set B? And remember, the union means everything together. So this set would have been 1, 2, 3, 5, and 7, right? That the union is all of it together, represents all of the numbers in the number set or sets. But then if we had another question that was A intersect B, the intersect just, what's the overlapping piece? What's the one that satisfies both sets? And a set like that would look something like this. We have set A is 1, 2, and 3, and set B is 2, 3, 5, and 7. The only overlapping parts are 2 and 3, so our set would look like this. So that's just kind of a quick refresher on what those symbols mean and how we use them. The U is union, meaning all sets that represent the number set, the new set, and then the intersection is just the overlapping part that satisfies both pieces of it. Okay, so with that being said, let's take a look at the first portion. We also have, besides our union and intersection, we have these new symbols right here. And it says use brackets for closed dots. In other words, is greater than or equal to, or is less than or equal to, right? So if you had greater than or equal to, and then less than or equal to, those are closed dots, okay? But now when we do interval notation, we're actually going to change that a little bit. And a closed dot, okay, is now equal to a bracket. And I kind of get kids to try and remember it this way. This means or equal to, and I go or equal to. Or it could be this way, or equal to, either way, because we use them together. We use them as a set. Okay? The parentheses we use for open dots. In other words, these are just greater than or less than. Okay, that's an open dot on a numbered line. So an open circle is just parentheses, and that's it. Okay? This U means union or all together, and the N means intersection. What's the overlapping part that satisfies both? Okay? All right, so that's the first thing. So we're going to look at this inequality, and yours on your paper it says inequality. Well, first, 0 is less than or equal to x, and that's so important, x is less than 4. And makes it a compound inequality, and that's stating that x is part of both inequalities, and so we would write it like this, well, just as we read it. 0 is less than or equal to x, and x is less than 4. That's how we read it. 0 is less than or equal to x, and x is less than 4. Okay? And then if we graph it on the number line, the way I tell kids to graph these on the number line is do it in pieces. In other words, this is just a basic inequality. X is less than 4. So I'm going to graph that. X is less than, which is an open circle, 4. And then I'm just going to do it the other way, and I'm going to cover it up on this side. And I'm going to say, only I'm going to read it opposite, x is less than or equal to greater than, x is greater than or equal to 0. X is greater than or equal to 0. And this, since it's an and word, that means intersection. In other words, what satisfies both. And the only inequalities, or the only real numbers on our number line that satisfy both inequalities is everything in between. We call this an and statement. Okay? Notice that we've got an open dot on one end, closed dot on another. Now here's something that's kind of, it's not written on your paper, but it's a little bit different. Think of it this way. Our open dot is represented by parentheses. So we could also write it like this. A parenthesis sitting on the 4. And the 0, right? 0 is less than or equal to x. So 0, or right here at 0 we'd have or equal to. We would have that bracket. And then it would be everything in between. Okay? And that's a new way that you can write it on the number line. That doesn't look very good, sorry about that. But, okay? Now, interval notation. This is how you write it. All right. When you have an and statement, you look at the outer two numbers, the 0 and 4. And by the way, they should always be, not always, but they should be going in ascending order. In other words, the smallest number on the left. It's just easier to read it that way, that's all. So write down your two numbers, 0 and 4, and kind of write them in the format of an ordered pair. Okay? And then look at the first part. Okay, 0 is less than or equal to x. That means next to this 0, I'm going to state, and you kind of do it the same way you graph it, it's less than or equal to. Just like that. And then on the right side where the parenthesis is, that's next to the 4, x is less than, it would be a parenthesis. And that's interval notation. Okay, kind of a different way to graph a compound inequality. 0 is less than or equal to x, and x is less than 4. And here's how we graph it on the number line. Okay? Here's example number 2. We've got -7 is less than x, and x is less than 10. That means that x is our and portion. It satisfies both inequalities. So now we're just going to write it. -7 is less than x, so -7 is less than x, and x is less than 10. Right? I wrote it just the way that it's written. Now I'm going to go and graph it, and I'm going to graph it both ways for you. So we have -7. Let's see, 1, 2, 3, 4, 5, 6. -7 is right here. 10 is all the way down here. And this is just less than, right? And less than. So I'm going to do the first portion. X is less than 10. So I know on the 10, it's an open circle. And then if I look at the other side, right? X is greater than -7. Okay? X is greater than -7. And the and statement means it's everything in between. Everything in between. Okay? -7 is less than x. X is less than 10. It could also be written like this with parentheses because it's just the less than. There's no or equal to part. And of course then you would have to draw the line in between the two. Okay. Now to write it in interval notation, this is an and statement, so look at the outer two numbers. -7 and 10, you write it like an ordered pair, -7 and 10. And remember, the open dot, just the less than or greater than, is a parenthesis. So, since -7 is less than x, a parenthesis next to the -7. X is less than 10, parenthesis next to the 10. Looks like an ordered pair, but that's actually interval notation. Okay? All right. What I want you to do right now is I want you to pause the video. All right? So I'm just going to put a little note here. Pause the video. And then I want you to flip over onto the back side and do those problems, and then we'll go through and we're going to talk about them. So pause the video now. All right. Hopefully you found that pretty easy. So let's just go through it. Okay? For number 1, and I'm not going to write all of these out word for word. I'm going to abbreviate a little bit just to make it go faster. But we've got 2 is less than or equal to x, which is less than 5. So 2 is less than or equal to, I'm sorry, I meant to put x is less than or equal to 2, and that's the most important part, and x is, and I'm just going to write the symbol less than 5, just to shorten it a little bit. Okay, so now we have to do our interval notation. Let's start here. We've got a 2 and a 5. Let's write them like the ordered pair. 2 and 5. 2 is less than or equal to x. So I look at my 2, and I know it has to have that or equal to part. Okay? And x is less than 5. Next to the 5 is just parentheses, because it doesn't have that or equal to part. 1, 2, 3, 4, 5, 4, 3, 2. Okay. Now we graph it. X is less than 5. That means I've got an open circle on 5, and it's going to be less than. And then x is greater than or equal to 2. X is greater than or equal to 2, and we connect it. If you were graphing an interval notation, it would be a bracket because it's or equal to, and then a parenthesis, and you would connect the two. Okay? Next one. We have x is, and I'm going to go less than or equal to 0, and I know I'm abbreviating, but I want you to write it out. X is less than or equal to 7. Okay? Interval notation, we write it like the ordered pair. 0, 7. It's less than or equal to, so you've got that less than or equal to. And then x is less than or equal to 7, you've got or equal to. Look at 0 and 1, 2, 3, 4, 5, 6, 7 on the number line. And we know that it's or equal to. An and statement is always connecting 2 points on the number line. In other words, we're saying all real numbers between 0, including 0 and 7, would satisfy this inequality. So it's an and statement is always connecting the two. All right? It could also look like this. Okay? All right. X is less than -6, and x is less than 4. Okay, interval notation. Write it like the ordered pair. -6 and 4. They're both just less than. That just means parentheses. Kind of looks like an ordered pair. I've got -6, 1, 2, 3, 4, 5, 6, -6, and 4, 1, 2, 3, 4. There we go. Okay, and since they're just less than, they're open dots, and we connect them. Or we could use parentheses and connect them. You'll see mostly this way, but I'm just kind of showing you both. All right? And then the last one on the bottom, sorry about that little 4 got moved. It should be over here. Okay, so x is less than or equal to -10, and x is less than 0. Again, I want you to write those out in words, but I'm just trying to save time on the video. Interval notation, like an ordered pair, we say -10 and 0, right? We write them like the ordered pair. And since they're both just less than, just kind of like the one above, it's just parentheses. Hopefully you're getting the hang of this now. These would be open dots, and you'd be connecting the two. Or again, it could be parentheses, and you could connect the two. Your call. Okay? All right. Next one. So, example 3. Ignore this little question mark. I don't know why that's there. All right. So, x is greater than -1. This looks like a normal inequality, and this looks like a normal graph. Okay, so nothing different. And we know that if x, is greater than -1, we know that it can't be 1, but it can be 2, 10, 50, infinity, whatever. it just can't include -1. So this is a basic inequality. What we don't have on here is infinity, right? It's just, we never say it, but this really means that all real numbers greater than -1 would satisfy this inequality. All real numbers greater than -1, all the way to infinity. So we're going to start writing it with infinity. Okay? We can go on forever and ever and ever, but obviously our number lines don't go that far. Okay, so this is how we write it. We would say x is greater than -1, right? We've got x is greater than -1. Okay. We start with, we're going to do the same thing. It's going to be like an ordered pair, only we're using infinity. In other words, it's just greater than, so it's going to be a parenthesis. And if you have greater than, that means you've got a number going to positive infinity. We never thought of infinity as positive or negative, but it is. Okay, so it's positive infinity. So we would say -1 to positive infinity. And here's the trick. So whenever you have infinity, it's a parenthesis. And kids, there's always the question, why is infinity a parenthesis and not or equal to infinity? And the reason is infinity doesn't have a value. It doesn't have a value, and therefore it can't be defined, so you technically can't stop at infinity. Okay? That's why infinity or negative infinity has a parenthesis. Just memorize that. Okay. Now let's take a look at it. You know what it looks like already. It looks like this, -1 to infinity, but you can also write it like this. You could also say -1 to infinity. Right? This is the way you see it, and this is the way you'll continue to see it from right now until you're in calculus, but this is what you'll eventually see. Maybe even algebra 2. Okay? All right. Next one, let's just try a different kind. So now we have x is less than 2. Basic inequality. If we were to put that in a number line, I think we know what it would look like. Here's 2. It's or equal to, so it would be a dot. And then we would write this arrow, right? But what we don't say, or what we haven't been saying, is that this means that all real numbers less than or equal to 2 to negative infinity would satisfy this equation. And you have to start looking at it a little differently, because we would write it like this. Okay, so we have x is less than 2, less than or equal to 2. Okay. Whenever you have less than, don't think of it as 2 and everything less than that. Think of negative infinity stopping at 2. Going from negative infinity and then stopping at 2, and that's how we write it. If you have a less than, negative infinity comes first. Okay? And again, parentheses anytime you have infinity. Comma for your ordered pair, 2. And since this is a less than or equal to, it would be or equal to. Okay? And so that's how you would write the interval notation for this one. Negative infinity to 2. Negative infinity to 2. All right? You could also, if you were doing this on a number line, technically you could go like this. But this is a more traditional way that we'll see it for right now. All right? So what I want you to do is I want you to pause the video again. Okay? And I think there's 3 or 4 on the back side. Let's see, 1, 2, 3, 4. There's 4 on the back side. Go ahead, pause the video, practice those, and then come back and we will talk about the final kind. Okay. All right. So let's take a look. So I'm going to do the same thing here just to save time on the video, and I'm going to abbreviate even though I want you to write out the inequality in words because it's important that you understand the words. So this is easy. This is just x is greater than or equal to 2. Okay? Interval notation. Okay, so it's greater than, which means you're going to start at 2, and you're going to be going this way, right? So think of 2 to infinity. 2 to infinity. Infinity always has parentheses. And since it's greater than or equal to, it's or equal to. Greater than or equal to. Okay? Of course, this would be a closed dot. All right? And again, if you wanted to get crazy, go ahead and write it that way as well. All right? Next one. X is greater than 0. Okay. So interval notation, we start at 0. It's just greater than, so it's going to be an open circle. All right? This looks like a traditional graph. Interval notation, we know that we're going to start at 0 and move to infinity. So 0, infinity. Infinity always has a parenthesis next to it. And since 0 is just greater than, it's just parenthesis, greater than. Okay? Again, if you want to get crazy and graph it that way as well, that's fine. Okay. Third one. X is less than or equal to negative 3, so X is less than or equal to negative 3. Again, I'm abbreviating. I want you to write it out. Interval notation. We're starting at negative 3. We know that it's less than or equal to. That's a closed dot. All right. So now you have to think about it this way. I'm starting at negative infinity. It's negative infinity to negative 3. So it's negative infinity to negative 3, and that's how you write it. Negative infinity to negative 3. Infinity always has parentheses because it doesn't have an exact value. And since this is less than or equal to, we have the or equal to bracket. Okay? And if you want to get crazy, you can grab it this way as well. Last one. Let's see. Last one for this one. Okay, so X is less than 4. Interval notation. We have, let's see, starting at 4, 1, 2, 3, 4. It's just less than, which is an open circle. So, negative infinity to 4. So that's how you write it, negative infinity to 4. We know infinity always has a parenthesis, and since this is just less than, there we go. Okay? Okay. Last piece. Last piece. All right. So, now we're moving on to the OR statement. The OR statement, remember, it's this or this, that's union. It's this or this. The other one was AND, which was the intersection. If you remember, and I'll just put it back here for a minute because it's important. When you had the AND statements, AND means between 2 points, right? AND means between 2 points, okay? An OR statement, OR means it's going to be either this or this, but nothing in between, okay? All right. The inequality, if we wanted to do X is less than 0 or X is greater than 3, you're going to write it just the way it's written, okay? X is less than 0 or X is greater than 3. Okay, you're going to write it just the way it's written. Now we're going to graph it. We're going to do the same thing. We're going to go to, what is it, 0 and 3. So we're going to go to 0. X is less than 0. X is greater than 3. So this inequality, this compound inequality, is essentially saying that all real numbers less than 0 and greater than 3 would satisfy this inequality. Okay? Notice we have our negative infinity and infinity. This right in between here is your or statement, right? It's either this or this. Okay? Now, let's graph them. X is less, or I'm sorry, write in interval notation. X is less than 0. Okay? The individual part of it would be like this. We know that it's a less than, so that means you're starting at negative infinity and stopping at 0. So we have negative infinity to 0. And since it's just less than, it's also a parentheses. This one right here, x is greater than 3. We start at 3 and we're going to positive infinity, so we write it that way. 3 to infinity, positive infinity. And since it's just greater than, it's a parentheses, and infinity always has parentheses. Now, you bring these two together, and you would write it just like that. You would say negative infinity to 0, or 3 to infinity. But this, for interval notation, should be union. Okay? Negative infinity to 0, or 3 to infinity. Okay? So kind of putting all the stuff together now just with a few more symbols. So go ahead and pause the video, do the last ones on the last page, and then we're done with this portion and we'll do some practice stuff. Okay. All right, last page. Here we go. We're going to write it in words, but like I said, I'm going to abbreviate. So this would be x is less than or equal to negative 5, or x is greater than 0. The interval notation, these are two separate inequalities that you're writing. So the first one is x is less than or equal to 0. I personally find it easier always to graph it first. That's just me. You don't have to do it that way. So less than or equal to negative 5 or greater than 0. So that's what your graph is going to look like. Okay. Again, if you wanted to do the bracket and the parenthesis and write them, that's fine. But you'll see the traditional method for until you get into the higher levels of math. Okay. So here we go. X is less than or equal to, we know it's less than, so it's negative infinity to negative 5. Negative infinity to negative 5. Infinity always has parentheses, and since it's less than or equal to, union, right, that's the or statement, union. We know it's going to be 0 to infinity, 0 to positive infinity. Okay, and since it's just greater than, it's parentheses, and there you go. All right, next one. X is less than or equal to 3, or x is greater than or equal to 10. Okay, interval notation, negative infinity to 3. Let me see, 1, 2, 3, and 10. Less than or equal to 3, and greater than or equal to 10. There we go. All right, I like to graph it first. So we have negative infinity to 3, negative infinity to 3. It's or equal to, so we have parenthesis or equal to, union. And then x is greater than 10, so we start at 10 to positive infinity. It's or equal to, so or equal to, and then parentheses. And there you go. And once again, if you want to do the brackets, that's fine. Last one. Okay, x is less than 0, x is less than 0, or greater than 2. I'm abbreviating, sorry. Okay, so interval notation, x is less than 0, okay, and x is greater than 2. That means all real numbers less than 0 and greater than 2 would satisfy our inequality. Okay, so interval notation. Negative infinity to 0, right? Negative infinity to 0. And since it's just less than, it's a parenthesis. union, and then greater than, so now we have 2 to positive infinity, and since it's just greater than, and there you have it. Okay? That's it for this one. So what you're going to do now is you're going to pull out, there's a practice worksheet for you to work on, and the substitute, Miss Kendall, should have a key to it, and I'm trying to find, I don't want to show you the answers to it because the one I have has the answers. It looks, yes it is. It looks like this, and at the top it says practice, turn into substitute when completed. All right? Okay guys, so that's it for this one. The homework that you have, it looks something like this. So this is, it says turn in to the substitute when completed, so you're turning this in for classwork grade, and your homework looks like this. Okay, this is your homework. It says homework at the top. And what you're doing on this, just to give you an example, is that you've got a combination of and or statements, and I'll help you out with the first one. This one is just saying, so they give you parts of it and you have to fill in the rest. So where we have x is less than or equal to 3, right, the interval notation would be, oh, it's negative infinity to 3, so you would write it like this, negative infinity to 3. It's less than or equal to, so or equal to, infinity always gets parentheses. And when you're doing your graph, make it easy on yourself, and you only have to like graph 3 numbers. In other words, write the 3 and then just do 1 number below it, 1 number above it, and then graph it from there, less than or equal to, and that's it, okay, when you're doing your graphs. All right, and then that's it for your homework. All right, guys.